Every contour map starts out as a plan view showing the location where we have measured elevation. I want to use this simple plan view with elevations collected on a grid to illustrate how we generate contours. The first step requires that we draw some working lines to define the paths along which we will interpolate contours. On this map, we will generate 5-foot contours. That is, our contour interval will be 5 feet. So our contours will all end with either 0 or 5. Now, if we look carefully, our minimum elevation anywhere on this project is 208.0. And let's see if we can find our highest elevation. I believe it is 230.0. So that means the lowest contour we will see is 210, then 215, 220, 225, and 230. Those are the 5 values of the contours we will have on this contour map. When we consider any pair of points, adjacent points here, we have to consider where the contours will fall between those points. So we have to say which contours will fall between any pair of points. Well, first, let's just work around the boundary of this and we'll find out. Between 210.7 and 208.0, between those two elevations, a contour of 210 will occur. Here, between 208 and 210, nothing occurs there, but we will have a contour passing through 210. Between 210 and 216, we have 215. And then between 216.1 and 209, now we'll have 2 contours. We'll have 215 and we'll have 210. Let's take a moment and do just exactly that. Go ahead and pause the video and determine that around the boundary of this simple map. Okay, did you get the same thing I did? You see, between 215.1 and 218.3, there won't be any 5-foot contours, will there be? Because 215.1 is greater than 215 and 218.3 is less than 220. Now, the next step requires that we evaluate between all the other pairs. So first we're going to draw some temporary working lines. We want to draw lines where we know we are going to have contours crossing through. For those places we don't have contours, we need not draw the lines. So I can start by drawing a grid. I'm going to continue by saying I know I have no contours going between 220.3 and 225.0, so I'm not going to draw a line there. But I do have contours that will cross between 208.0 and 225. I know those will be 210, 215, and 220. I don't have any between 225 and 223, but between 210 and 223, once again, I will have a few more. See, here I will have 215 and 220 are the elevations for contours that will cross between those points at 210.0 and 223.0. So I'm going to go ahead and draw the rest of these, and I would encourage you to do the same thing. Now you can see that I've drawn those grid lines, and you can also see the elevations of the contours that will pass between the labeled elevations. Now I need to draw some more lines, and I want you to think of each of these lines as diagonals across these squares, across the grid. So watch as we work this out. At the lower left, I could be drawing a line going from 218 up to 230, or I could be drawing a line that goes from 220.6 to 215.1. The first diagonal I drew connects two adjacent points. I'm trying to decide which one of these lines I want to draw. I'm only going to draw one. So the rule of thumb I use is evaluate the two elevations you see here. If I look at 220.6 minus 215.1, that is a difference of 5.5 feet. But if I look at the difference between 230 and 218, that is a difference of 12 feet. So I'm going to draw the diagonal that represents the largest elevation change. I now have divided that square into two triangles. So I'm going to continue doing this throughout the rest of my drawing here. And I know I need to connect these two if I apply that rule carefully. And this pair gives me a greater elevation difference than if I went with the opposite corners. This is there, and looks like my greater elevation difference in this square is there. In this particular location, you can see that I've got a difference of 15 feet either way, so that is not going to matter much, but for this case I'm going to draw that diagonal. Between any of these pairs of points, somewhere along this line here, the 210 contour, the 215, and the 220 will occur. But I need to be a little more careful and determine where they will occur. So let me demonstrate something here with a drawing. Let me demonstrate how we calculate the location along this line where the 215 contour will cross this line. First, remember that the slope along the ground between any 2 points has to be assumed to be uniform. I don't have any evidence to the contrary that the slope of the ground is anything other than uniform. So what I've drawn here is a profile, and the bottom line here represents elevation 210, and the top line represents elevation 220. So the spacing between the horizontal lines here is 2 feet. This length from here to here also represents the length on the drawing of this little diagonal working line that I've drawn from there to there. Our challenge then is to figure out where along that line the 215 contour will be. So if we're imagining it, you and I can see that if this is 214 here and this is 216, well, 215 is going to hit about there. That point there is not really halfway between the endpoints of the line. Consider something here. I've got an elevation difference here of 9.1 feet, right? We took 210.0 minus 219.1, and I got a difference of 9.1. Now let's also consider the difference between 215 and 210 is 5 feet. So if I take a ratio of 5.0 over 9.1, well, that rounds to a ratio of what, 5 over 9? So what I'm saying here is this distance from the right end, or the downhill end of this line, to 215 should be 5/9 of that distance. This distance over here should be 4/9 of the distance. See what I'm showing? So over here on my drawing, I want the 215 contour to cross this line at about 5/9. So this distance here, that's 5/9 of that distance. And this distance here is 4/9 of that distance. So the 215 contour crosses right there. Now I want to demonstrate how we interpolate contour locations for lines where there will be more than one contour crossing. Let's take a look at this line right here. Its lower elevation is 213.00 and its upper elevation is 224.2, right there and right there. So that gives us an elevation difference of 11.2 feet. For our simplicity, we're just going to change that to 11 feet. So I've drawn a profile for you once again to illustrate. Remember, the ground slope is considered to be uniform along the line between the 2 points. I've got 11 feet elevation difference, and we will divide this length, that is the distance between the 2 points, into 11 parts. We want to find out how many parts of that 11 separate one end of the line from the nearest contour. Well, the 215 contour, I think you can see, is going to be right there. See it? This distance right there is going to be some fraction of this 11 units. Well, 215 contour elevation minus 213, which is the lower end of this line here, is 2 elevation units. So we have changed elevation. Remember, see, from here down to here, that is elevation change of 11 feet. Well, this is only an elevation change of 2 feet. So there should be a corresponding 2/11ths distance from this end of the line to the 215 contour. Let's think about this. If I think this whole thing is from there to there is 11 units, well, I'm going to estimate 2/11ths to be right about there. So my 215 contour is going to cross this line roughly there. Well, let's go back down here for a moment, and you'll see then that the 220 contour, which is the other contour that we can expect to cross this line, is going to occur right there. So I will then think of this as some distance from the end of the line that I started from. In this case, it's 213. And now that is an elevation difference from here down to here. That is a difference of what? 7 feet. Okay, so now if this distance was 2/11ths, then this distance is 7/11ths, isn't it? Back up to my plan view. So I'm going 7/11ths, and I'm going to estimate that to be right about there. So now, please pause the video and take some time to do this process on all of the grid lines and diagonal lines and the exterior of the map. And we're going to have a whole bunch of little tick marks. So, does your work look like this? Notice that in some places the tick marks that I've made are fairly close to the end of the line. Right up here you can see that the 220 mark is fairly close to 220.3, and then halfway between, roughly halfway between my tick mark there and 210.7, I have a mark for 215 right up there. Okay, so they're not going to necessarily be evenly spaced, but we want them to be proportionally spaced. Okay, so the next step is going to be drawing the contour lines. This is our lowest point. This is our highest point. And there are high points along the outside edges. Let's take a look here. If this was our low point along this edge, this is a high point along the edge. This also is a high point. If I go along this lower edge, I've got a little bit of a high point right here. And then I've got my highest point on this edge right there. I'm going to go with things that I know I can spot pretty quickly. And if I've got a high point, I know that I've got contours that make a circle around that. I don't have a 230 contour, but I will have a contour 225. So let me show you how this connects. Okay, I'm not drawing perfectly, I'm not trying to. Okay, but notice my contours connect. My contour connects the tick marks I have made where they cross the diagonal working lines. Okay, well, that's not a surprise that it's shaped that way. It does close on itself because it surrounds this peak. Then notice if contour lines tend to run somewhat parallel to each other, then I can expect that the 220 contour is crossing through, let's see, about like this. You see how that works? This 220 doesn't close on itself on our map because this line here is all higher than 220, isn't it? I've got 215 down here. I forgot to mark 215 on here. I think it's going to be roughly about there, which is consistent with everything else I found. And it runs off the map there. Now you might be wondering, well, why doesn't it connect to this one up here? Why not? Well, let's look. You see, I know that this point is 219 and this point's 217. Everything between that, if I drew a line here, is going to be higher than 217 and lower than 219. So I could not cross like this. That would be contradictory, wouldn't it? So you have to logically evaluate where can those things go. Now up here, 215 is going to come through like this. And then it will come down like this. Let me show you why that is. Once again, as we said before, a line drawn from 217 to 216 will never have an elevation on it lower than 216. So 215 can't possibly cross through like this. Okay, that would be inconsistent with the definition of the contour line. We've got a 210 contour that comes through like this, and it crosses through there, and then it crosses just right here. Let me clean this up for you so it makes a little more sense. So this is what our finished topographic drawing looks like. We can label these contours. You can see that this one is the 225 contour. This one is 220. This is 215. This one is 210. This one also is 210. And this one also is 215. And this is 215. So remember, our contour lines cross our working lines at points that we have interpolated along those lines. When we do this with AutoCAD Civil 3D or Bentley MicroStation and Geopack, they do the same thing, except they do it in an automated fashion. But by doing it by hand this way, you strengthen your understanding of elevation, of contour, and of slope, and you will have a greater understanding than you would have otherwise had by seeing the software do it automatically.